Thank you for introduction. Thank you for giving me this opportunity. So today I'd like to talk about positivity, the relation between positivity of anti-canonical divisors and effectivity of fibers. So we consider the next question. X and Y are smooth projective varieties over an algebraically closed field of characteristic, any characteristic, and F is surjective morphism. So question is what positivity is passed from minus kx to minus ky. So relaxing. There are some results related to this question. When f is smooth, if minus kx is some positivity, if minus kx has some positivity, then so it's minus ky. This satisfies when this part is ample. This is due to Professor Kora and Miyaoka and Mori. And this question is based on this result. And when this part is nef, this is also true. This is proved by the argument similar to this. And this result is in any characteristic. When star is nef and big, this is proved by Fujino and Professor Gonyo. And semi-ample case is due to Bilka and Chen. if a chain. So this is only characteristic 0. So next, when f is not necessarily smooth, there are some results in when characteristic is 0. If minus kx is nef and big, then minus ky is big. So this follows from a result of Prokhorov and Sokolov. And if minus kx is nef, then minus ky is pseudo-effective. This is due to Chang. Men Chen and Ki Chan.
Sorry, what is general? What singularity do you allow?
Sorry. This is no assumption. It means if it's not.
No assumptions at all? Not minus x, y, or
Sorry.
x, y, or s?
Yes, yes. But for example, this result is known for log canonical case. X is log canonical case. So this.
Yeah, so first part is okay, but
Yeah.
different
Okay.
the problem. The other one, I'm not sure I will find it.
Oh, okay. So sorry. Misconnected fiber. Thank you very much. So, before I explain today's main theorem, I introduce notion of weak positivity. So let G be a coherent sheaf on Y and H ample divisor and S is a subset. So G is weakly positive over S is if for every positive integer A there is some positive integer B such that this sheaf is globally generated over S. This is AB's symmetric product of G and this is the double dual. So yeah. Next notion is not common, but it's useful for today's talk. G is said to be big over S. If and only if. So there is the positive integer C such that this sheaf is weakly positive over S. So, usually this notion is used when S is an open subset or S is a singleton of generic point of Y. But today we use this notion. For line bundles on Y, weak positivity over S when S is Y, when S is total space. This is equivalent to nefness, and when S is the singleton of generic point, this weak positivity is equivalent to pseudo-effectivity, and bigness over Y is equivalent to ampleness, and S is the singleton of generic point. This is equivalent to big in usual sense. We can state the main theorem of today's talk. Impulsive characteristic. That's why we are smooth projective varieties. And F is surjective morphism. Delta is effective Q divisor on X. And large V is Q divisor on Y, and small d is integer, positive integer such that d is integral. So, and let S be a subset of y such that dimension of fiber is equal to dim x minus dim y, and support of delta does not contain any component of fiber, and geometric fiber over y is F pair, where y bar is geometric point. Sorry. If there is a subset of y such that satisfies these conditions, then the following satisfied. If the index of delta does not it's not divided by p, and if this divisor is nef, then this sheaf is weakly positive over S. Second. And if this same one, this is ample, then this sheaf is big over S, and if this divisor is nef and big, and for every point in S, scheme theoretic point in S, the fiber is strongly F-regular, then this sheaf is also big over S.
sharply appear, or is it appear? The one there, appear or sharply appear?
FPR. Yes. Not sharply FPR.
Not sharply appear, actually appear.
Yes, yes. Yes. Maybe. Maybe. Maybe either is okay. So here there is some remark. If FPR or strongly irregular is a singularity is defined by splitting of Frobenius, and if smooth and delta equals 0, then this implies strongly irregular, and strongly irregular means FPR, and strongly irregular is considered as closely related to KLT singularities, and also FPR is considered as closely related to semi-canonical singularities, and yeah, so part 2 and part 3 follows from part 1, and the argument from part 1 to part 3 is I was taught the argument from part 1 to part 3 by Professor Gonjo, and the assumption about index of delta was removed from part 2 and part 3 by the suggestion of Professor Patak Farabi. So, but today I'd like to explain part 1. And for simplicity, delta equals 0. Before, so, and first I introduce an example of constructed by Lennon and Sho. So this example implies we cannot remove the assumption of F-fility. So there exist quasi-elliptic fibulation. This is surface and curve such that there exists divisor on C that Kx is linearly equivalent to pullback of Ky plus L, but degree L is negative. this example, all of the fiber has cusp, and cusp is not F pure. And if we take D as minus ky plus L, then this is linearly equivalent to 0. So this is nef, but minus ky plus D is L, and this is not pseudo-effective. So we cannot remove the assumption of F-purity. So in order to prove the main theorem, we introduce trace map of relative province. In this section, X is Gorenstein and Y is Smith. We denote the absolute province by absolute province of X by Fx E, and E is E times iterative iteration. So this is fiber product, and we denote this morphism by Fe, but this E is just a symbol, and this diagram induce this morphism. We denote it by this. So by Grothendieck duality, we have and there is natural morphism to xy. So this composite denoted by phi ex over y. the effectivity is defined by this notion. X is F pair if X over spec now K is algebraically closed field of positive characteristic. This morphism is surjective for every E. So this proposition means means we can sorry. So this proposition is first the points of y such that geometric fiber is F pair is consistent open subset. So second, X is Princeton and y is smooth. Sorry. For every F ample Cauchy divisor on X, there exists an positive integer m0 such that for every E this is morphism, and this morphism is surjective. Where AYE is pullback of A, and WE is here. So I'll explain only sketch of the proof. part 1 is follows from the fact that this phi trace map is compatible with restriction. So if means this morphism is surjective, and if restriction is surjective, then this morphism is surjective over around fiber. This implies the co-kernel of this morphism has does not the support of co-kernel of this morphism does not dominate the base space. So part 1 is so okay. Second part is in order to prove this, we use relative Fujita vanishing and the iterative structure of this morphism. So, sorry, I omit this proof of this. Next, we introduce an invariant of coherent shifts, which measures positivity. Let D be a coherent sheaf on Y. And these two quality divisor, and this is a subset. The set of rational number such that there exists an E such that PE epsilon D is become quality divisor, and this sheaf is globally generated over S. And the small t is defined as the supplement of this set. And sometimes we omit D. This invariant satisfies some good properties. let F be a coherent sheaf on Y. If there is a morphism such that surjective over S, then T is F is at most TSG. Second, if this set is not minus infinity and plus infinity, so sorry, this is an element of R over minus infinity over plus infinity, and if this is not minus infinity and plus infinity, then we can define the sum of this, and we have inequality if tensor G. Part 3 is TS of Robbins-Fullback is equal to P times TSG for every E. Part 4 is TSG is if this is plus infinity and G is locally free over S, then Y minus DD is weakly positive over S for some D. DD is Cartier. So from sorry, part 1 to 3 is not so difficult. So I'll give the proof of part 4. So we may assume that this integral goes and let H be an ample divisor such that this sheaf is globally generated. So there is a surjection from trivial sheaf. So from this we have by taking tensor product with G, we have this surjection, and there's natural morphism to Y, H, and this is surjective over S because G is locally free over S. So by part 1 we have Ts over HD is again plus infinity. Some epsilon in an element of Ts, large Ts, there exists an integer E such that this sheaf is globally generated over S. This is by definition of large Ts. And this sheaf is isomorphic to P E epsilon minus D plus inverse epsilon H. And if epsilon was infinity, then this goes to 0. So this implies that y minus d is weakly positive over S. So, and we use this lemma to prove the main theorem. So I give a proof, but I have not so many times. So I give a very rough sketch. Sorry. So by proposition, we have by proposition, there is very ample divisor on X such that this morphism is obtained by push forward of trace map tensored by this divisor. So, and by proposition, this is surjective over S, and there is natural morphism from this is we can choose A such that this morphism is surjective by using Castiglione manifold irregularity, relative version of Castiglione manifold irregularity. So we use this notation. So, and we want to show there is some coherent shift such that this invariant is plus infinity. So then by lemma we have this sheaf is weakly positive over S, and so yeah. By this morphism, we have sorry. This is lower than or equal to this P come from Frobenius pullback, and this number come from this, and so in order to get this, we assume TSG01 T prime is a real number. This is automatically not minus infinity. So then by transpose this, and by assumption we know that this goes to infinity when e goes to infinity. In this part we use this is sorry, this is nef divisor. I'm sorry, I cannot explain. So this is a contradiction. So we get this number is not real number. So we get this is plus infinity. So we get the claim. I stop here. Thank you very much.
Questions or comments?
Why do you have FPU instead of Sharky FPU?
So when delta is just a Q divisor, then there is a difference. This or
yeah, so this is sharp view. Yes, that's sharp. Yeah.
And so in our situation, the fiber is just a Gorenstein variety.
Yes, it doesn't matter.
So yeah, and so we cannot round it down, but we can replace this round up. We can this is surjection. This is surjective is equivalent to for for every E such that is satisfied. Yeah, this is equivalent, and this we don't need round up or down. So I use FPDT.
So any other questions? Then it's time to speak again.
Thank you very much.